And then, yeah, so you can see that she's kind of developed some mathematical, like simple maths and like simple calculations. So, yeah, and it's kind of giving this very beautiful wavy effect in the larger scale. And the work that we are looking at today is this one. I always forget the name of this piece. Touch Me Not. Yeah. So, which is actually, I think, like really small little pinpoints made with some similar light object and kind of placed on the wall. There is a little video here which shows you how they installed it as well. So it seems like a really massive job, like to do all of it. But I, I personally find these very interesting because my own practice is around space design and project management of spaces. So I like to see this kind of stuff come to life in a way. Okay, so uh, we'll try something simpler, maybe not something so complex. And then maybe tomorrow we can try to see if we can kind of make it a bit uh, more complex and interesting. The sine cos format is now split into 2 days. The reason is that today we'll just like do a little about sine and cos in themselves, and then tomorrow we will do more on polar coordinate system, which allows you to do things in almost like circular fashion and things. And there's a very nice website for this, which I've used in the past as well, called Maths is Fun. And they have some really good explanations for this. So we'll just do a simple understanding of what is that dog really bothering, or is it okay?
No, that's okay.
Fine. Okay. A simple explanation of sine, cos, and tan. So if you had a if you had a right angle triangle, this is your 90 degrees. So and this is your hypotenuse. So for the hypotenuse obviously always opposite to the 90-degree angle. Uh, this becomes the adjacent angle. So when you want to calculate the sine theta, it all works with this hypotenuse and the two sides with it. So here is your adjacent side, and here is your. So now if you're looking at this angle, and this is your opposite side. Oops, lost internet. Sorry, got dropped for a bit. Sorry, did you get this? The opposite and the adjacent sides?
No, I couldn't hear you.
Okay. Yeah, I'm also a
Sorry.
bit sick today, but is this better?
Ah, oh no, I think it was the
The
connection.
connection, okay, okay.
Yeah,
So if this is your right angle triangle with the
yeah.
90-degree angle, and sort of this is determining how the triangle is moving. So like it could be this way, so this could be your angle, or your angle is this big, so your 90 is like very slight like that. But for the just for the example, we'll keep it here. So if this is theta and this is your hypotenuse, this is your adjacent side to the angle, and then this is your opposite side. So
Okay.
sine theta and cos theta are, I think, opposite, adjacent upon opposite, opposite upon hypotenuse, sorry. Uh, so opposite upon the hypotenuse, which is this, gives you sine theta, and then adjacent upon hypotenuse gives you cos, and then tan is basically I think opposite upon the adjacent. Opposite upon. So tan we don't use too much. Like, I'm still figuring out how it fully works, but now think of it like this. So if you have this sine theta opposite over hypotenuse, my opposite can be calculated by sine theta times hypotenuse, like I brought this here, equals to opposite. So if my sine angle keeps changing and my hypotenuse is fixed, I can see that some kind of pattern emerges when my angle is also moving. But we'll not go there yet. But we've got a basic understanding of sine. Sine gives us this value, right? So we also know that that sine, I mean, this is like just general knowledge, that it moves like a wave, which basically means it starts at 0, it moves up to 1, goes back to 0, -1, 0, 1, 0, -1. So you see a pattern emerging. It's 0, 1, 0, -1, 0, 1, etc., and so on. So this is an interesting opportunity to look at things that might like move in and out, or like move back and forth. So it's giving you values that are moving from a certain from certain -1 to a 1, right? So if I multiply this by 100, it would give me -100 by 100, right? So some interesting opportunities emerge from this. And on P5.js, cos and sine can be called fairly simply by just typing sine all small, and then adding the angle, whatever angle you want, and it'll give you some values. So we'll just see how this works now. So for example, in the setup, I'll just write sine, and I have not changed the angle mode, so I'll continue to say, like, first I'll write 0, so it'll give me value 0, then I'll do pi by 2, which is 90, which gives me 1, and then I'll do pi, which gives me 1 point something something, and then if I do 2 pi, which is 360 degrees, it goes up till -2 or something. So if I were to say I put angle mode degrees, and here instead of 90 was pi, so if I put sine 90, it should give me 1, right? But here instead of sine 90, suppose I wrote frame count. Now this is in setup, so it will not give me anything, but I'll put it here, and then you'll see that suddenly a lot of numbers are emerging, and you can see it went to -1, and then it's coming back to 0, tending to 3 or something, and then coming back. So it's giving you like a wave, right? So pretty easy to use then. So say for example, I were to put this in a circle, and I didn't do any variable right now, I'm just using it as is. It's moving so limitedly that we can't see it. So like, say if I multiply by 100, then it'll give me, and it'll go all the way to -100, obviously. So this gives me some interesting opportunities to play around with the so I'm so sorry, with the code. So for example, if I were to say I equals 0, I is like, I don't know, 6, I plus plus, then I'll add this, I'll copy paste this inside, and instead of y, I'll say I times 30. So now I have so many of them moving together. But I think I still may want to, like, let them move a little bit, like, differently. So let's see how we can do that. I also have to remember now how I did it. Today I have come a little unprepared because of my health, but hopefully we'll reach somewhere at the end of it. So this should give me the same result because I haven't done much. But if I take this inside the for loop, maybe it'll, yeah. Now you can see that they are moving slightly different from each other, but really fast also. Maybe oh, it's too little, too slow. Okay, keep it back at one. See what we can do maybe. So maybe this could be an offset. I'll call it like let's call it x offset, and then this starts at 0, and maybe s x offset does plus plus or something. Looks like a machine, yeah. Oh, it didn't give me the result I was expecting. Mm. Okay, one sec. Let me just try to pull up some old code and find it. Oh,
Oh, wow.
okay. Okay, so we'll try this one only since it's open. Okay. So here there's no loop as you can see, and I've set up a for loop, and I've given it an offset for the angle, and then it let's ये text को हटा देते हैं यहाँ से. Maybe I'll take it there and then it'll be a little bit clearer to me. Oops. Oh, okay, so I've made a loop that goes up till the end of the canvas, and I made an angle. Did it have? Oh, okay, sorry. This, and I made an angle which is 0, and then has an offset which I've kept as y, and okay, so I've used map in this. So basically I've used a sine. I've taken the mapping of sine from -1 to 1, which we know, and I've mapped it to 0 to height, which basically means everything will be mapped in the y direction from 0 here to height. It's not a fixed one. And everything in the x direction is just simply a multiplication, nothing major. But the difference is that there is an offset here for the y, which is 0.2. Why does it look different here though? Because of this? No, that's already there. Ah, okay. I'm a little confused. Okay, maybe let's go one by one.
I think the angle mode is different in both.
Ah, clever.
Ah.
That was quick, Navya. Are you sure you don't want to take this class instead of me today? I'll be happy to give it over to you for the day. Yeah, sorry. So the angle mode is was in pi, not in radians, not in degrees. So here we've given it an offset, which is uh, allowing the sign of a here, which was otherwise just going to go up by 0.001. And currently you can see that there is an extra, there's a with the for loop here. So the offset is within the for loop and the general increment is outside of the for loop. So that means for every time the project is the background is refreshing, that increment only happens that one time, but the offset increments every single time within the for loop. So based on the number of increments. So if it's going up till 600, that means the offset is for every single x, the offset is coming out to be for y is coming out to be different. So this was just the, I don't know, that's like the shortcut way of doing it today. But we can do it again properly. Maybe if that makes more sense for the learning. This was just more like a bit of a. So, okay, so I'll just try it again with you guys. So yeah, so this is, we'll set up the for loop and of course we'll remove angle mode. Now we could do y equals to sine of x, and then let's just see what it gives us if we were to keep this times 100 maybe. So it is giving me, so it's basically moving, all of them are moving right here in this one line, because it's between minus 100 and 100 again. So if I want to translate this, somewhere here. So now it's basically 0 is here, minus 100 and 100 is up till here. So now basically what we did was that we fixed it here. So instead of that, we'll just increment it by whatever, 40, I guess. So it's kind of giving a wave, which is not necessarily a very smooth one, but you can definitely see it. Right?
Oh, yeah.
Oops. So yeah, so now I've increased the increments in the for loop, which is automatically giving me a like a higher number of circles within the wave. So this is primarily because here when you're taking, so now if I were to console log this value y, so it's giving me a bunch of values. Where can we see a 0 closer to a 0? Okay, maybe 9 is the closest to a 0. So we turn this up, it's going minus and then goes back to see like this 6 here. But if I have a lesser number of increments, which was plus 1, perhaps we can look at this in the setup. That might be easier. This will happen only once now. Yeah. So it's given me a fair number of values and it's going up till 100, right? Because so up till the width, which is the number of values is given me. But perhaps if it's like, I don't know how many these are. I wonder how you can count these. So, and if it's point whatever we kept it, 0.6 or something.
Yeah.
So the increments you can see are a little bit more, giving quite a lot of values compared to when it was 1. So it's just to kind of like populate your sine wave, I guess. Whatever. Right, and then so then now we can try to bring the offset. So maybe we wanted to like move a little bit. So obviously we aren't at a place mathematically where we can kind of yet move it like this, but we can definitely create an illusion that if our circle is here, that it's moving in that same spot across. So it's creating that illusion of a wave, so which is what we were doing here with this. So it's kind of, if you see like this spot, it's actually just moving on the same x-axis, but it's the y-axis which is kind of making it appear as if the wave is kind of moving across. So for that, I think we just need to have that offset value now within the loop. So we can define an offset value of, sorry, which we can add here in the sine, and then perhaps let me just offset it outside to see what happens. Plus equals to, okay, so that's just giving me per loop, so obviously nothing will happen. Okay. अरे ये तो कुछ और ही कर रहा है, sorry guys. Okay, got it, sorry. So now, so there are two offsets. One is the overall angle, and then one is the offset. So now instead of x here, I have to change it to angle and then give the offset of the angle to be okay, maybe. Oops, what did I do? So basically, the first angle, which is in the offset, is kind of determining how fast it's moving, and this is kind of determining how populatedly it is shifting, I think. Yeah, like so, if you look at maths is fun, this should give us some idea. If we look at sine wave, yeah, so like the wavelength and the amplitude. So currently this has a very high wavelength because of the offset. So this is and then the amplitude is then just determined by the 100 or the 200 that we have. Okay. So the I don't know if someone wants to read this. The person who suggested this maths is fun link to me is part of the committee that makes the CBSE mathematics books up till class ninth or something. So then I thought to myself that if that person knows about some fun link like this, why isn't the book so much fun? And why did I hate math so much when I was in school? Or maybe these are new things. I don't know. Mm, yeah, so this is kind of sorted. So now here, of course, then the same kind of values apply. You can change the shape out. You can make this a text. So if I use this and then x times 40, comma.
A little while ago, you had it where it was like a double, like it was like
I
a double
think that
wave. I don't know how
was,
you did that.
was something like this? I don't know. Bit of guesswork. Let me just shut the loop. It's kind of slowing my computer down a bit. What did I do?
I have to watch the video back. Try and work out.
I think I should be able to tell you in the next class because that will be a little bit about Rose mathematics and all that. So some bits so that might be in that. I'm very out of sorts today. I'm very sorry, but
I'm sorry that you're not feeling well.
it's okay. Okay, maybe I just go back as much as I can.
Oh, that's it.
That's what you wanted, no? Yeah,
Yeah.
I remembered when we went back. Because now it's the increment is the value of the increment is actually so much higher that the wave is kind of like I don't know how to explain the math, but like maybe I don't know, maybe Chandaji can help us in this, but uh, let's just say get the console log here to see the difference in the sum of the values. Perhaps it will give us an idea. Today the computer and the brain are in a similar kind of slow state. Okay, it's not, I think it's too much for it. So much console log. Okay. Yeah, so here I guess now you can kind of, for at least for the part where you see this one by Ranjini, you can kind of like have a couple of them and experiment like with multiple lines of the circles to see and different angles to figure it out. I leave that to you guys. है ना? And and now you know how you can use text also in it, so that's also like a nice way to explore this. Cost should also give us a very similar look, but I think the wave comes out the other way around, or just like this phase shifted or something like that. So there's not much difference, but like if I do tan, it'll be like it's kind of own thing is happening. So, and then say if you added like a little bit of, do a nice trail of it or something. See, this is the reason, like once you read Sine, you think you can be a VJ very quickly, because like just changing one or two things makes it look so beautiful. And then of course, like you can add this stuff to color and things. So like you want to like say maybe we are in a color mode, which is like HSL or whatever, and then we can fill it with Y and then 100. No stroke. Oh, sorry. Maybe that was too much for it. Ah, okay.
Wow.
Sorry if it's too stroby. So yeah, so this has some interesting possibilities. And then of course like very simple things could include like save like like the radius could be sine of frame count times 100, and then your circle is at a fixed place. Well, it should so yeah, so those are some like simpler possibilities, or just like move it across, which is what we did in the beginning, I think so. So yeah, so like you can try it out in different ways, but my recommendation is to continue with the Ranjini Shettar artwork, which is this one. And I think there were some very nice ones that people ended up doing. Let me see if I can find it. I think it was there in the presentation. Oh, this is yours, sorry. Like Anisha has done something very nice. It's Louisa has done something quite nice as well.
Yeah.
So you could not have a circle necessarily. Maybe you could use a custom function and have a custom shape. that you want to try in this, or or what else can I do with sine which looks interesting? You can do something with the text as well, like maybe it comes and goes. The transparency is based on sine or something like that. And then we can say map it. So this is to whatever this we wanted this to be, like I don't know, 0 to 255, and then fill could be based on that. So this isn't like, this one isn't running so smoothly, so maybe like I have a smaller angle. I don't know if that'll make a difference. Yeah, this is a bit smoother, right? So this is the same logic we had there, that uh, if you're moving, if you need to move from 0 to 1, and you know that 0 comes from sine 0, and you get 1 from sine 90, right? So the more the increments in between these two, okay, now I've got the logic to tell you. Obviously, it comes to me like a very little bit late. So the more the increments, the finer the increments, the smoother the value will move across this. So, for example, if the frame rate here is console.log, let's see what is the frame rate here is 14, right? So what should be the frame count? I guess 14 frames per uh, yeah. So it's changing like frame rate per second. So 14 frames per second. So that means if I do this, the increment is every second it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But if I do by 10, then that increment is uh, frame rate per second is 14 divided by 10. So that's 1.4. So then so like in one case, the first case, my x plus equals to is 14, and in the other case my x plus 2 plus equals to is 1.4. So obviously this increment is smaller and this increment is more discrete. Sorry, I'm drawing all over the place, but I guess you understood what I'm saying. I think some people are nodding, so I'm assuming.
Did you mean that the smaller that number, the smoother
Yeah,
the
the smoother this the movement will be, because you're getting more values between say this range, or whatever that range is that you've given. So so even in general, say if I had something that's x equals to x plus 1, and the other thing is x equals to x plus 10, and I'm asking two circles to move, so the first circle will move one pixel per frame or whatever, the other one will move 10, right? So it's a little bit more discrete. So if I were to add that same value, that x value, uh, to my sine, in the first scenario, it will give me those many values. So then, even if it is going from 0 to 1, it's going in a smoother way. But here it's going from 0 to 1 in this in these larger steps, so then I can only see it in a more like discrete manner, and not so smoothly played out. So we can, I think frame count is a bad way to think about it. If you were to just think about it like x equals to 0, and then in one scenario, and then maybe we keep that not in the fill but instead uh, in the radius, and in one scenario the x equals to x plus 1, which was a little bit discrete, or I could do x plus equals to 0.01. So that will give me a little bit of a smoother set of values. So here you'll observe that normally my sign goes to minus, right? But here you'll see that after 0, it's pretty much coming back, right? So if I were to use a map function, I could also do the same thing. So instead of the values mapping the values from, sharing the variable values from 0 to 1, they will be remapped from 0 to 255. So it will go up to 255, go to 0, and then immediately it will come back through that range. So, or if, so the other way to look at this is, say this was 40 and a y value is changing, right? So here you'll see it will go back, it will come back, and then it goes right up minus whatever. But here I've kept it 0 to 255. There's no minus. So instead of the r, if I replace this with m, it will move from 0 to 255. But it still gives me that same effect, that same sign effect. I don't know if this was, did you guys get this bit? Oh no. Jenny, you okay with it? Chanda ji? Shraddha?
Okay.
Yeah. Okay, cool. So yeah, so these are some ways to kind of work with sign to come up with some fun things, that whatever you're thinking about in terms of your animations uh, and uh, and other kind of things. So like imagine, I could also imagine this like the way yesterday Chanda ji and Jenny have used an array of images. So like if we were to arrange the array of images in that sign, is that a possibility? So for example, if we had a array of words, let's just make it can we then bring that the words in the array like how we had done in the text, no? So can we bring those words of the array out into the sine wave? I don't know how we'll do that. I'm just thinking aloud. So so someone had done something very nice in that format. Can't remember now. So perhaps like I equals this, and then I is less than the array length. And then if this and then here maybe my r value is x value is I times 20, and then m, I guess. So all the words are coming, but maybe then this guy is inside the, what did I do wrong? M is not defined.
Oh,
Uh, they are not discrete, no? Okay, I mean it's populating, but it's only four of them, so I don't know if it's really worth it. Maybe if there was a longer list. Oh, sorry. Was it this one, Navya? Cheer.
No.
Here we had an offset, right? Plus, was it plus?
Yeah.
I don't know what this will give us, but okay. Anyway, sorry, today's bad. But yeah, I mean, yeah, you could like try some other experiments in this way as well. Like maybe you don't need to just use circles. You could use text. You could use images. You could use webcam. I don't know, maybe like an array of yourself moving around or something. And then sorry, a wave of yourself moving around. Then oh yeah, so the one other thing that I haven't, it's not a very big thing, but the like I don't normally tell it in the beginning is that like if you don't want a particular thing to work in your code, you don't necessarily have to delete it. You can just comment it out with the which you can do with two slashes like this. Uh, So what that does is you can quickly check. The reason it's called commenting out is basically people who do code like for a living and do it properly, they put comments everywhere so you know what's happening. So you just write two slashes like that, and then you can add, this is the draw setup. I have added a circle there. So it's just a way to document whatever you're writing, and so it's called comment. So, but the common terminology now has become, let's just comment out the code, which basically means you convert it into a comment. So the program no longer understands that it's piece of the code and doesn't try to run it. So this is useful when you're trying things out, like you wanted to try circle instead of text, or you wanted to not have the fill or have this fill and not have that fill, and just like explore those ideas a bit. So, yeah, that's about it for this session. Tomorrow we'll look at polar coordinates, which are also part of this. And if we have some time, oh, not tomorrow, next Saturday, and some things on rose mathematics, which is quite beautiful looking. I can show it to you also. I think you may remember this from your spirographs and things when you were little. So basically, I think I have a couple of examples. Maybe I can just pull them.
Wow.
So it's slowly building out that kind of rose, or like a flower or whatever. And then I don't know if this is the same one or something different. So I think at this point you will start observing that many of the things we see on the internet, when we see the hashtag generative art and processing, tends to come from a couple of algorithms that are sign based. So now you'll start seeing those patterns, perhaps be able to build some beautiful things in that format or reject it. I don't know, whatever you prefer. Uh, yeah, so you can, so we'll do this next time. And Yeah, and then so that's the Saturday session, and then we are done. So after that, if you guys want to do a little show and tell, we can do that. I'm happy to stream it so you guys can tell your friends, and maybe people can join and see what you guys are up to. So we can do that on the Sunday after that, which is 6th is the Saturday and 7th is the Sunday. I don't know if people have like Diwali related things, but I don't think I have anything. So if anyone is and if anyone feels like they might miss it, then we can try to like adjust a date that works for everyone. I'll put it out in the same email group that this is the plan. And so the show and tell needn't just be your work. You can just kind of talk about what you are interested in exploring further. Maybe we will give us a sense of how we can bring this community out to others, and what it means. Like, I think except for Kushal, everyone's been this time the sessions has been women, so that's quite interesting. So it'll be nice to have everybody in the showcase. It'll be a new format for coding with friends. Yeah. So cool. So we'll meet you now next week.